Hi guys, welcome to today's tutorial. Today we'll be looking at statistics and probability. Now, our definition on statistics is, what is statistics? Now, statistics is the study of the collection, analysis, interpretation, presentation, and organization of data. Now, we first of all gather or collect data. Then we analyze. From our analysis, we interpret. Then from our interpretation, we present it in a more understandable manner or way for the audience to understand what we are doing and organization of our data. Now we'll look at some basic key points of under statistics. Now the first is data collection. Now what is data collection? Data collection is gathering of information or data through different means. We have a survey, we have experiments, we have observation. Now, next we'll be looking at is data analysis. Analysis simply means examining the data, to identify patterns, trends, and the relationship among a set of data. Another key term to understand is measure of central tendency. Now, when we talk about measures of central tendency, we talk about the mean, the median, and the mode. These are the three major areas of measures of central tendency. Now, when we talk about variability or measure of spread, we talk about our range, our variance, and standard deviation. Now, we look at types of statistics. We have the descriptive statistics. That's our first aspect on type of statistics. Now, the descriptive statistics summarizes and describes our data. Now, we use our measures of central tendency and our measures of spread to understand the descriptive statistics. Now, under descriptive statistics, we have our mean, median, mode, range, our variance, and standard deviation. Now, what is mean? Mean is the average value of a set of data. Now, when we talk about our mean equals the summation of all our data summation of all our data all over the number of data, which gives us the average of that set of data. Now, a median is referred to as the middle value of a set of data. Key point, when arranged in ascending or descending order. So when we have a set of data, it must first of all be arranged in order, either ascending or descending, before we can find the middle value to give us a median. And when we talk about mode, mode is the most frequently occurring value in a set of data. Now, next we are looking at is range. Now, what is range? Range is the difference between the largest value and the smallest value in a given set of data. When we talk about variance, variance is a measure of spread or dispersion. Now, our variance and standard deviation helps us to understand how wide apart or how wide apart a set of data is. Now, descriptive examples. Now, for us to calculate, it says for our mean, calculate the average value of the set of data. Now we have 2, 4, 6, 8, 10 as our set of data. Now for us to find the mean, we sum up 2 plus 4 plus 6 plus 8 plus 10, which gives us 30. Now 30, how many? 1, 2, 3, 4, 5. 5 numbers. So 30 divided by 5 would give us 6. That means the mean of this set of data is 6. Next, we'll look at find the median of this set of data. We have 1, 3, 5, 7 now. Now, in this order, it's already arranged in ascending order. So from 1, 3, 5, 7. Now we are looking for the middle number. So if we count 2 from our left and 2 from our right, we can see that we have 5 as our middle number. So 5, the value 5 becomes our median. Now, For mode, it says identifying the most frequently occurring value. Now, among 2, 2, 3, 4, 2, which value occurs more? Now, we can see we have 3 2s, 1 3, and 1 4. So our mode will be 2 because it occurs most frequently. Now, the first we looked at in our types of statistics was our descriptive statistics. Now we are looking at our inferential statistics. Now, inferential statistics simply draws conclusion and makes prediction about a population based on a sample. Now, this is majorly used in the statistical world to draw predictions about how certain events would be from a sample of population. All right. Next, okay, under there, we'll be looking at hypothesis testing. Okay, now hypothesis testing talks about where you test a hypothesis on a population. Okay, out of a group of or a set of people, you select certain number of people as your sample space and test your hypothesis on them to know how it will affect the entire population. The next we look at is a confidence interval. Now, this is helps in estimating the population parameter using a sample. Okay. Now, example of our inferential statistics on hypothesis testing is to test a hypothesis about a population. If the average height of a population is 175 centimeters, okay, now our hypothesis H1, our null hypothesis, which is our null hypothesis, is it has no effect. And our H1, which is our alternative okay, has effect, has no effect. Okay, now our H1, our H0, which is null, has no effect, and our H1, which is our alternative hypothesis, has effect. So you base this, if it has no effect, what's the outcome? And if it has an effect, what's the outcome? So you check on the two. Now, the confidence interval, this estimates the population parameter. Example, the average weight of a population within 95% confidence. Now, if our sample mean is 70 kg and the percentage error is 2 kg, our margin error is 2 kg. So our confidence interval will range between 70 minus 2 to 70 plus 2. So that's why we are having it as 68 to 72 kg as our confidence level. Now, at this confidence level, if it's less than 68, it's unacceptable. If it's greater than 72, it's unacceptable. So it has to fall within our confidence level for it to be. Probability is the study of the likelihood of an event to occur. Now, the chances that an event would happen or take place leads to probability. Now, basic concepts under probability, we have experiment. Now, this is a situation or trial that produces an outcome. Okay? Now, we talk about outcome. An outcome is a specific result of an experiment. Now, example of an experiment is rolling of a die or tossing of a coin. Okay? Now, the outcome of rolling of a die is that we either get numbers between 1 to 6. Now, that is specific. Or we toss a coin, it's either it lands with its head or a tail. Now, that's an outcome. Now, when we talk about the sample space, the sample space is the set of all possible outcomes in an experiment. So for a die, right, we have 1, 2, 3, 4, 5, 6 as our outcome. All right. So the total sample space here would be 6. All right. Since there are 6 possible outcomes there. Now for a coin, our outcome would be just a head and tail. Now the sample space would be 2. Okay. Now an event is a set of one or more outcomes. One or more outcomes forms our events. Okay, just like we've explained before. Now, an experiment, like we said, is a rolling of a die or tossing of a coin. Okay, a possible outcome are getting any of those numbers. Okay, the outcome of rolling a 4, which is one of these, or a 3 or a 2. Now, our sample space is our numbers between 1 to 6, which gives us as 6 as our sample space. Then rolling event is rolling of an even number. That means we have more than one outcome to form our event. Now, looking at our rules in probability, we have the addition rule, okay, where we have probability of A or probability of B. Now, probability of A or B would be probability of A plus probability of B minus probability of A and B. Okay, the probability of A occurring and plus the probability of event B occurring minus the probability of A and B. This is like saying probability of A plus probability of B plus probability of A intersection B. Okay, now we'll look at examples on them as time goes on. Now, for the multiplication rule, we have probability of A and B, that is probability of A times probability of B over A. Okay, probability of A times probability of B over A. Now, which brings us to our conditional probability, where we have probability of B over A to give us probability of A and B all over probability of A. Okay, now that's for our probability rule. Now, example on addition rule, we have it as the probability of rolling a 2 or a 4. Okay, the probability of rolling a 2 or a 4 would be the probability of rolling a 2 plus the probability of rolling a 4, which gives us probability of rolling a 2 in a die is 1 over 6. Probability of getting a 2 in a die is 1 over 6. And probability of getting a 4 in a die is 1 over 6. So adding the 2 together brings us 1 over 6 plus 1 over 6, which gives us 2 over 6, which when brought to its lowest term would be 1 over 3 as our answer. All right, now looking at our multiplication rule, it talks about the probability of getting a 2 and then a 4. Okay, probability of getting a 2 is 1 over 6, and probability of getting a 4 is also 1 over 6. So the probability of getting a 2 and a 4, it will be 1 over 36. Now, since it's multiplication, 1 times 1 will give 1, 6 times 6 will give 36. So the probability of getting a 2 and the probability of getting a 4 will be 1 over 36. For the conditional probability rule, let's look at our example as a deck of 52 cards. Okay, what is the probability of drawing a king given that the card is a face card? Now, our step-by-step solution is first we'll define the event. Okay, our first event from our question is the probability of drawing a king. Now, our first event is to draw a king, and the second event is a face card. Now, on my card, we have the king, the queen, and the jack. So we call our event A the probability of drawing a king, and event B the probability of drawing a face card. Now, to calculate, the next step is to calculate the probability of event A and event B. Now, we know that in a pack of cards, there are 4 kings in a deck of 52 cards. There are 4 kings in a deck of 52 cards, and we have 4 queens and 4 jacks. So now, there are 4 kings in a deck of 52 cards. The probability of picking a king will be 4 over 52. Okay? Now, let's calculate also the probability of our event B of drawing a face card. Now, since we have 4 kings, 4 queens, and 4 jacks, the probability of getting a face card will be 12 over 52. Now, applying our probability conditional formula, where we have probability of A over probability of B, which will give us probability of A and B all over probability of B. Okay? Now, our probability of A and B is the probability of drawing a king, which is 4 over 52, divided by the probability of drawing a face card, which is 12 over 52. So, in inverse of this will give us 4 over 52 times 52 over 12. This will cancel this, leaving us with 4 over 12. 4 here 1, 4 here 3, which gives us 1 over 3. So the probability of drawing a king, okay, or a face card out of our pack of cards will be 1 over 3. Now, the next we'll be looking at will be probability distributions. Okay, now we have the discrete probability distributions, which deals with our binomial distribution and our Poisson distribution. Now, the next one, the second one is a continuous probability distribution, which talks about the normal distribution or your uniform distribution. Now, looking at our binomial distribution, our binomial distribution helps in modeling the number of successes in a trial. Okay, example, we have in 5 trials, we have 3 successes. That becomes 5 combination 3. All right, so times 0.5 raised power 3 times 0.5 raised power 2. All right, now that's the model of how our binomial distribution on probability goes on. It deals with more of our combination than permutation. Now, our normal distribution models continuous data with a bell-shaped curve. Now, the model our normal distribution deals with a bell-shaped curve, okay, for our distribution. All right. Now, talking about our statistical inferences, what we have our hypothesis testing. We have the null hypothesis, which is a statement that has no effect or no difference. Okay? Our null hypothesis has no effect or it makes no difference on our testing or on the sample being tested. Then while the alternative hypothesis is a statement of the effect or the difference it has made on our sample population. Now, looking at our test statistics, this talks about a numerical value used to determine the significance of the result. Okay, a numerical value attached or placed or used in expressing or used to determine the significance of our result is referred to as our test statistics. Okay, next we've talked about our null hypothesis, which is our H 0, our alternative hypothesis, which is our H1, our test statistics. Okay, next we'll be looking at will be the p-value. Now, the p-value, the probability of obtaining the test statistics or a more extreme value, assuming that our null hypothesis is true. Okay, that gives us our p-value. When we assume that our H0, which is null hypothesis, is true, what will be the test statistics at that point when the null hypothesis is 0? Will give us our p value. Now, talking about point estimate. Our point estimate is a single value used to estimate a population parameter. Okay? Point estimate is a single value used to estimate a population parameter. And next we'll be looking at is our interval estimate. Now, this is a range of value used to estimate the population's parameter. Now, first we looked at point estimate, which is a single value. Now, interval estimate is a range of value that we use to estimate the population parameter. Now, when we talk about margin of error, the margin of error is the maximum amount by which the sample estimate may differ from the true population. For an example, if we have our average to be 70 kg, okay, and we give a margin error of 2 kg. Now, our margin error will range between 70 minus 2, which is 68, to 70 plus 2, which is 72. So our margin error will be 2 kg, and the range of our values will be between 68 to 72 kg. All right. Now, we're looking at the applications of statistics and probability. One, it can be used in business and economics for forecasting, quality control, and decision making. Two, it can be used in medicine and healthcare for clinical trials, epidemiology, and health research. And three, it can be used in the social sciences for understanding human behaviors, attitudes, and the opinions of people. And four, it can be used in the engineering for quality control, reliability, and risk analysis. Now, it is important to know that statistics and probability helps us to understand data, make informed decisions, and predict future outcomes. So, the study of statistics is necessary for future to make precise decisions and predict our future outcome. All right, guys, we've made a detailed practical questions on statistics and probability. If you haven't seen it, ensure you check the channel for the video. Thank you.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Cacao, NET, IELT, and the likes like that. Also, in every video you watch, we have the link to our apps where you can download on Google Play Store and Apple Play Store and practice hundreds of past questions for free.